What's going on YouTube? Welcome back to the Thomas Gallery, and today I want to talk about black holes. What are black holes? Now, if you're from Washington D.C., black hole was an old club that got shut down years ago. Inside joke, don't worry about that. But if you are not familiar with that, a black hole is simply a massive black hole in space that sucks up stuff. But the question is, how is a black hole made? How's a black hole made? Where did it come from? Where did it come from? Huh? Well, black holes are made from dead stars, in a nutshell. And the stars go through a process. And I'm going to actually not only explain to you, but I'm actually going to show you what it looked like with using my artistic skills. Y'all ready? All right, here we go. This is my chart of black holeness. Now, there are mainly three different kinds of stars. There must have been three different kinds. You have your white dwarf, you have your yellow sun, like ours, and you have your big red giants, okay? These two are what you really want to focus on at the particular point. The white dwarfs and the red giants, okay? Black holes will form when these red giants, which are the much older stars, get old and they get really old and they die. RIS, or rest in space, okay? They die. And what happens is when these stars die off, what's left behind is the core of the star, okay? The core of the star, okay? Yeah? Just the core of the star left, okay? Or the white dwarf star. The white dwarf star is the core of a dead star, okay? Now, what happens is when the gravity gets such where it can't be stable, this star begins to collapse on itself. Okay? It begins to collapse on itself and it forms at its center of its core a black hole. And when this black hole forms, two things happen. One, the black hole forms, but before that, the star explodes, which is called a supernova. A supernova is an exploding star, okay? And what's left behind is the black hole. Now, the black hole, because its mass is so great, the black hole sucks up everything that's close to it, that is within its gravitational pull, okay? If it can pull you in, it's getting pulled in. You're not getting out. Not even light can get out. The force is so strong from a black hole that not even light can escape from it. Okay? And see, everything gets caught up in the black hole. Everything is caught in the black hole. All matter and mass gets caught up in the black hole if it's nearby. Now the black hole don't just wander around space just walking like do 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 do, and it just eat up stuff like Pac-Man. No. It stays there. And if anything gets close to it, or if anything gets within its gravitational pull, it eats it. It swallows it up, with just like that. And the thing is, a black hole is a three-dimensional hole. That means that it's a hole in space that it gathers in all matter and mass from all different sides. Okay. Now the question would be I'll put it down now. The question would be, well, if it's a black hole and space is black, how can you tell? How do you know it's a black hole there? Well, easy. When things start looking like a funhouse mirror around that area, that's when you know something happening. Hold on right quick. Back to what I was saying. If a black hole is black and space is black, well, how do you know there's a black hole there? Well, the thing is, no, you cannot see black on black, no. But what you can look for is what's surrounding that area. If the area around that black hole starts looking distorted like a funhouse mirror, you know, go to a funhouse mirror, you look all distorted and you got your hair looking one shape and then your body looking all elongated like that. If the materials around that area gets distorted, you know that there's something there at a center that is doing that. And what's doing that is the force from that black hole. is so great that it distorts space around it. Now, you got to talk about matter and mass when you're dealing with that. Two different things. Matter, for those who don't know, matter is simply an object. Matter is an object like this. This is matter. This is matter. I'm matter. I'm matter. Okay? Matter. The phone is matter, right? Mass is the measurement of the amount of matter in an object. Okay? So, for example, if I were to ask the question, how much does the earth weigh? That's a different question from how much mass does the earth have. Okay? Your weight, how much does the earth weigh? The answer is nothing. The earth weighs nothing. Okay? But how much mass does it have? Meaning the measurement of the material, the measurement of matter, of how much matter is in an object. The measurement of how much, yeah, that's mass. Mass is the measurement of how much matter is in an object. So collectively, how much matter is in the planet Earth? And you wouldn't get a pound number. You do like in tons and kilograms and all that stuff, metric system stuff. And it's 6 septillion tons. That's the mass number of Earth. But how much does it weigh? Nothing. Because it's in space. It's moving in space freely. Well, the more mass an object has, the greater the force. And since the black hole has such an immense mass, its mass is so great that it takes in everything. So if the higher the mass, the higher the gravity. That's why when something is thrown up in the air, it falls down, because it's falling to the thing that has the most mass, which is the center of Earth. The center of Earth, because it's so condensed, has more mass. So when you throw something up, it goes down. That's what comes down. In order for you to escape that force, you would have to surpass the gravitational pull of that object. Escape velocity, okay? But with a black hole, the mass is so great that nothing can escape it. Not even light. Light is the fastest thing we know that is known in the universe. Light, which travels at 186,000 miles per second. Not even light is fast enough to escape the gravity of a black hole due to its immense mass. Because remember, the core of the star is so dense. Now, once you go beyond that density, you reach a black hole. Because you have surpassed the density of a core of a white dwarf and gone to a black hole, the mass is much greater, because you have taken that core and you have put it into an infinitesimally small space. It's the equivalent of putting imagine putting 5 billion elephants into this. Imagine putting the weight of 5 billion elephants into the size of this phone. Okay? The mass would be greater, because mass is just adding things into this small space. That's a black hole. Imagine putting something the size of a red giant and condensing that into a white dwarf. Now, the mass has just been condensed, but you have condensed it into a smaller area, making it that much more greater, making the mass much more greater. You take that same white dwarf and then you condense it even more into a point so small it can't be quantified. The point is so small it can't be quantified. So the mass is so great that anything near it gets sucked in, and it ain't getting out ever. It's not getting out. There ain't nothing strong enough to escape the gravitational pull of a black hole. Not even light. So that is essentially what a black hole is. Hope you like my little diagram, my little drawing there, and I got a lot more. Hope you enjoy it. Peace.